will discuss something about algebraic. Before studying about algebraic expressions, let us know some concepts which are related with it. First thing is literals. These are the letters which are used to represent the numbers. For example, 3x, y. X and y are literals. Second thing is, what is a constant? This is a term having no literals. For example, 28. It is a constant term. Or we see the expression 3x plus 7. In this expression, in this term, 7 is a constant because it is not having any literal with it. It has a fixed numerical value. The next concept is, what is a variable? It is a symbol which takes various numerical values. For example, X, Y, A, B, all these things are variables because they may assume different values in the different situations. Now, what is algebraic expression? Algebraic expression is a combination of constants and variables and which are connected by the addition, subtraction, multiplication or division. That means it is combination of variables and constants. They are connected by the various signs: addition, subtraction, multiplication and division. Now there are certain types of algebraic expression. The first type is based on the types of algebraic expression are based on two categories. One is based on number of terms contained in it, and the second type is based on degree of polynomial. We see something about the number of terms. If an algebraic expression contains 1, 2, 3 or 4 number of terms, accordingly it is classified as monomial, binomial, trinomial and quadrinomial. That means a monomial will contain a single term, binomial will contain 2 terms, trinomial will contain 3 terms and quadrinomial will contain 4 terms. And if an algebraic expression contains more terms, it will be called that an expression having n number of terms, maybe 4, 5, 6, 7 or anything. Examples of monomial may be 7x, 3x, y cube, 9 minus 28, y square, and so on. All these are having single term. Next is the second category is binomial expression. Here bi denotes 2. That means any expression having 2 terms which may be connected by either addition or subtraction. 2 separate terms connected together are known as binomial expression. For example, 12xy plus 35. It is having 2 terms. First term is 12xy square and the second is 35y. Or a plus 10. Here again there are 2 terms. First is a, another is 10. Or n square minus 10. In all the examples, literals or the variables are different. In the first case, variables are x and y. In the second, variable is a, and in the last, variable is n. That means an algebraic expression can have any variable in it. Now, what are the trinomial? The word tri denotes 3. That means if there are 3 terms, it is a trinomial. For example, 5x minus 7y plus 10. It is having 3 terms in which one is a constant term, 10. 12x cubed plus 7y square minus 18x. It is also a trinomial. The fourth category is quadrinomial. Quadrinomial is having 4 terms. For example, p cube plus q square plus pq square plus r to the power 4. This is having 4 terms in the variables p, q and r, or we can say a square plus b square minus c square plus 13. It is also a quadrinomial because it is having 4 different terms. And if an algebraic expression have more than 4 terms, it is known as expression of 5, 6 or another terms. After knowing about types of algebraic equations, let us know about something more terms which are related to the algebraic expressions, and the first one is factors. In any algebraic expression, every term is product of some numbers or literals, and all these numbers or literals are known as factors of the terms. For example, in the term 7xy plus 18z, in this expression we are having two terms 7xy plus 18z, and by taking the first term 7xy, it is product of 7x and y. That means 7 is a numerical factor, x and y is a literal factor. These are known as the factor. And the second term is coefficient. Every factor is the coefficient of remaining factor. For example, 5pq. In this, 5 is coefficient of p and q, or we can say p is coefficient of 5q, or q is coefficient of 5p. That is the coefficient. It may be number or literal. And the next term is like terms. In the algebraic expression, if the terms are having same literals, they are known as like terms. For example, 6x square y minus 5x square y, 13xy square 2xy. In the four terms, we can see that 6x square y and minus 5x square y are having the same literals. That means they are like terms. And the final concept is what is unlike term. Is the name suggests that the terms which are not like are unlike terms. That means which are not having the same literals. For example, 3p square q plus 5pq square minus 9pq square plus 10pq. In this expression, 3p square q, 5pq square and 10pq are the unlike terms. But 5 and minus 9, these are having the same letters, they are like terms. Now the second type of classification is based on degree of polynomial. Degree of polynomial. Before knowing about this concept, we should know something about polynomial. What is a polynomial? We'll define the polynomial. It is a specific type of algebraic expression in a single variable algebraic expression whose format is given as a0 plus a1x plus a2x square plus, and it is continued up to certain number of terms, for example n. Now We have defined this expression in the variable x, so we can write it a polynomial in variable x. Here a0, a1, a2 up to an all should be the real number. This is a major constraint for the polynomial. All are the real number, and the exponent which is given to the variable x is a non-negative integer. It is a non-negative integer. For example, x to the power 5 minus 35x plus 10. If we have to check whether the given expression is a polynomial or not, we'll check both the contents, that is, the coefficients should be real number and the exponent should be a non-negative integer. For all the terms, the exponents are non-negative. Here it is 5, in this case it is 1, and in the third term there is no variable, so we can write it x raised to 0. Again it is a non-negative integer, and all the constant a0, a1, here the constant is 1, in this case constant is minus 35, and finally the constant is 10. So it is a polynomial. There may be other examples also. 35 x to the power 100 minus 12 x to the power 7 plus 5 x to the power 3 minus 18. Again it is a polynomial where the exponents or the powers given to the variables are non-negative integer 100, 7, 3, and all the constants are real number. Now we see an example which is not a polynomial, that is x to the power 4 plus 5 divided by x minus 13. Why this is not a polynomial? Because in the second term 5 divided by x, and it will be written as 5x to the power minus 1. So the exponent or the power is a negative integer, which is in contradictory statement for the definition of polynomial, so it is not a polynomial. After defining the polynomial, we can see the classification which is based on the degree. So we must know about the degree of polynomial. In any polynomial, the exponent which is given to the variable n and which is the highest is the degree of polynomial. That is, we can say that highest exponent of variable. If the polynomial is contain the term a and x raised to n, then n will be degree where its coefficient should be non-zero. Otherwise it will not contain the term of x raised to n. The highest exponent of variable is known as its degree, and the degree may be minimum 0 and maximum up to any natural number. So the classification can be done that 0 degree polynomial, 1 degree polynomial, 2 degree, 3 degree and 4 degree. First of all we see that what is 0 degree polynomial. As in this case the degree of polynomial should be 0, that is the variable x should have a 0 exponent. So all the constants are 0 degree polynomial, because we can write them as 7x raised to 0 minus 38 y raised to 0, or any variable. The first example is in the x variable and the second is in y variable. These are the 0 degree polynomial, or we can say that they are constant polynomial. The second type is whose degree is 1. That is, the expression will contain, or the polynomial will contain, the highest term of x raised to 1. For example, 7x plus 10, 5x minus 19x plus 55. All these are examples of 1 degree polynomial because these are having the maximum variable term in the x raised to 1. They are also called the linear polynomials. In case of linear polynomial, it is necessary that the polynomial should contain a term in x raised to 1. They may contain the constant or may not contain the constant. Now the third category is degree 2 polynomial. As the category suggests, these polynomial must contain a quadratic expression, that is x raised to 2. They may contain the linear or constant term or may not contain the. For example, 7x square minus 13x plus 10. It is a 2 degree polynomial because the highest exponent of the term is 2. It is containing the linear and constant, but there may be certain examples which are not contain the linear terms, like 55x square. It is also a 2 degree polynomial. Next category is degree 3 polynomial. Similarly, it will contain the terms of x to the power 3 and the power 2 linear or constant term may or may not be existing. For example, 15x to the power 3 minus 8x square plus 10x plus 7. It is a degree 3 polynomial because it is containing the cubic expression. These are also known as cubic polynomial. Now, any other polynomial of higher degree are known as their degrees name. For example, polynomial of degree 5, 6, 8 or anything. Polynomials of higher degree are specified by their degree. We may ask to identify the degree of polynomial in any given expression, and for this purpose we must notice this thing in mind, that the polynomial should be in the simplest form. There may be certain terms which will eliminate after the simplification. For example, it is given that x to the power 7 plus 5x cube minus x to the power 7 plus 8x square plus 18. Now, in the first look, it gives an impression that the polynomial is of degree 7. But when we simplify the expression, the terms x raised to 7 is cancelled with the minus x raised to 7, and the resultant expression is only the 5x cube plus 8x square plus 18, and hence the degree will be 3. So we must simplify the given expression and then identify the degree. Let us have one more example. The polynomial may be given in the form of dividing any two terms, and they may give after simplification a degree which is different. For example, x raised to 10 minus 16 x raised to 12 divided by x plus 5x cube minus 100. If we try to simplify the observation, then the second term is simplified n, it is written as x raised to 11 because power 12 is cancelled with the power 1 of the denominator, and so the resultant degree is 11 because the highest term is x raised to 11. About the operations which can be carried out on the algebraic expressions. First of all, let us see the addition and subtraction. For adding any two algebraic expression, first of all we should notice that only like terms can be added or subtracted. Only like terms can be added or subtracted.